I welcome you once again to another video session on Mat 242. So considering this particular question, we want to use gamma function to evaluate the following integral. So this is the first question. And for the second question, sorry, let me use another color for that. So let's deal with the first question first. Let's do it first question before we come straight to the second one. We have up to 5 or 6 questions under this. 5 or 6. So let's solve this first one. So the first question says evaluate this integral using gamma function. Okay, so how are you going to deal with something like this? One is very, very simple. At first, you need to start with gamma definition. So what is gamma definition? Definition of gamma simply states that the gamma of n is actually equivalent to the integral of 0 to infinity. This limit, the limit for the integral must start from 0 and it must tend to infinity. Take note. The integral of 0 to infinity of x is to the power of n, okay, minus 1, then e is to the power of negative x dx. So this is the definition of gamma of n. So that means looking at this definition here, I can easily relate it with something like this. But on one condition, make sure you don't have any coefficient for x aside from negative 1. Immediately when you have um any other coefficient for this x, then you need to use substitution method to evaluate the integral. That should be the first thing that should come to your mind. Take note of that. Immediately when you notice that this x has any other coefficient aside from negative 1, then you need to automatically use substitution method for it. Is that clear? So that is how that is going to work. Okay. Now I also noticed this 6 now can be expressed as 5 minus 1, or you use 6 plus 1 minus 1 so that this negative 1 can actually come out from there. Do you understand that logic? And I notice if this has minus and this does not really have minus, looking at it, okay, then that means that there should be an issue. So if I check the question well, so I'm very, very sure there's a negative sign there. There should be a negative sign. Okay, should be a negative sign. So I've checked the question just now. There's a negative sign for the question. If there's a negative sign, then I'm not sure whether gamma function can actually work for that, because there's no way you can actually compare this with the definition. So guys, since I've been able to give you the definition for gamma, you need to understand this clearly. Gamma of n is always equals to integral of x. Look for a variable x to use. Look for a particular variable to use. This n is a constant. It's a set of real numbers. Okay, but not just any real numbers. Okay, because you can't look for gamma of anyhow fraction. So there's some other function that has a solution, while some remain as a challenge problem. Like you trying to look for gamma of 3/7, that's going to be a lot of work and problem for you. Okay. Look for a variable, okay, and then raise it to this constant value minus 1, then take exponential negative of that variable. Like how can you actually detect that? What if I don't want to use variable x? Okay, this is gamma of n. So that means automatically I can have 0 to infinity. So the concept of this thing is, because sometimes you feel like, is this thing X or E? So you need to be very, very careful. So that will get confused. So whatever you have to do from here is to just go ahead and look for any suitable variable that you want. Let's say I want to use T. Let's say I want to use T. The variable T I want to use, you write it out. Then this N, raise it as an index and then put minus 1. Automatically speaking, after writing the variable and the power and the index expression, so you just need to take exponential straight up and then take the negative of that variable you use. Then you put D of that variable. That's the thing. I can use another letter if I like. Okay, I don't want to get to this. That's how I'm trying to try. That's how I'm trying different variables, 0 to infinity. Let's say I want to use variable x, for instance. Variable x. Okay, I've used x before. Let's say I want to use another variable. Let's say I want to use p. Then that will be p is to the power of n minus 1. Then e is power of negative p. Then dp. But the common variable that I can actually use most of the time, that people use in all textbooks, is x and this t. That's what we use most of the time. So this one is not really necessary. Or you can use p anyhow you want it. That's if you want your solution to be unique. Okay, and then now we have this as definition. What are we going to do? I noticed that I want to solve this question. I noticed if I am seeing one here, I said the constant to compare now we need just one. The equation you must have for this x should be negative one, but now I'm having negative two, so I have to sort that out. So how are you going to do that? You need to use substitution method, like I said. So that's for us to use substitution method. I have integral of 0 to infinity, then x is to the power of 6, then e is power of negative 2x dx. So then I'll start with let u represent the whole of this power. Okay, probably I don't consider negative sign. Let me just consider this only, so that the negative remain there. So I only consider this. I will look for a way to transform this 2x back to x so I can compare. So let u represent whatever you have up there as 2x. Then if you look for du over dx, automatically speaking, that will give us 2. So when you cross multiply, you have it as trivially looking at this dx now. I want to make this dx the sorted formula. In fact, that means I want to transform this x back to u instantly. Okay, since I'm already using substitution method, it's going to affect this x automatically. So now guys, since we have this, okay, I have du over dx equals to 2 cross multiplied, and I have it as du is equals to 2 dx. Now let's make this dx equal to the formula. Divide by 2, automatically speaking, dx will be equals to du over 2. So these are the things that I need. Okay, and then u is already equivalent to what? 2x. So if u is equals to 2x, if u is equals to 2x, now also you need to make dx the sort of the formula, and as well make x the sort of the formula. So my x, when you make x sort of the formula, I have my x to be equivalent to u over 2. So these are the two things that you need to substitute. Okay, these are the two things that you need to substitute into this place. So now I need to consider the limit as well. So for the range, u is equals to 2x. That was the substitution I did, right? So and this range is for x. It's changing with respect to x, right? So that means when x is 0, what will be the value for you? When x is 0, when x is equals to 0, what is u? When you substitute that here, you have 2 times 0, you have u to be equals to 0, which is still equivalent. So when x is equals to infinity, what if x is equals to infinity? That's taking 2 times infinity. That's you multiplying infinity twice will still be infinite, right? So that means I still have the same range for both range for x and u. They are equivalent in that regard. So it does not really change the limit for the expression. So now I have 0 to infinity. X is equals to what? U over 2. Substitute that's u over 2. Then you raise it to 6. Then e raised to the power of negative. What is 2x? 2x is equals to u. Then what is dx? Dx is equivalent to what? To du over 2. Okay. Now, since you have this, you can easily simplify. This is 1 over 2. The 1 over 2 can actually come outside from the integral. So if the 1 over 2 come outside from the integral, then I'll be left with 0 to infinity. This is u over 2 is power of 6. By the law of indices, I have u is power of 6, then 2 is power of 6, then e negative u, then du. Next thing for us to do is to go ahead and take, this is 1 over 2. There's an invisible one here. 1 over 2 is power of 6 can as well come outside. 1 over 2 is power of 6, then 0 to infinity. So I'll be left with just u6, u raised to the power of 6, e negative u, then du. Now looking at this clearly now, I notice that I have 2 times 2 is power of 6, that's 2 is power of 7. And then finally, we have 0 to infinity of u6, e negative u. And nobody will tell you, because this particular integral here looks exactly like it's actually equivalent to that of the gamma function, the definition for a gamma function, whereby I have another variable. That's why I actually explained that variable in that case. Now you see that this one is now variable u raised to the power of something, then I have negative u. So automatically speaking, since I noticed that this is your own main target, just make sure that you check this part. Immediately when you notice that there is no coefficient aside from negative 1, then you can go ahead and compare. So by the time you compare it with the standard definition, whereby we always use it as x raised to the power of n minus 1, e raised to the power of negative x dx. So that means for us to look for n now, you just need to equate, this thing here is equivalent to gamma n, right? So you need to look for n. U is equals to x, which is still the same. That does not really affect. This does not really affect. So I'm only interested in looking for n, so I can easily get the gamma of n. So that means negative u is equals to negative x. Still the same thing. I can even use u in that case. I can change this to u. I can change this to u. So if I equate it now, standard form of gamma function is equals to gamma n. So that means I only need to look for n. That is equate this n minus one and this six together. Equate them together. Okay, that is n minus one is equals to six. Now solve for n. That's n is equals to six plus one. Okay, that's six plus one, and that's seven. Okay, this goes like this. I have seven. So that means automatically speaking, I have this whole expression here as gamma of n, and gamma of n is gamma 7. Okay, where n is 7. So remember that gamma of n, I believe you still remember this. There's another definition of gamma, the properties of gamma, which says gamma of n is actually equivalent to when you deduce that n by 1 and then make sure you take the factorial. There's a proof for that. Okay, gamma of n is equals to n minus 1 factorial, that is reduce it by 1. What if you want to look for gamma of n minus 1? Okay, gamma of n minus 1, that will be equivalent to n plus 2, sorry, n minus 2 factorial, because you need to deduce it by 1. That's the concept over there. That's n minus 2 factorial, that is n minus 1 deduct minus 1 as well. That's n minus 2. What if you want to look for gamma of n plus 1? That will now be equivalent to deduct 1, that's n factorial. But we are only interested in this. Okay, and there's a proof for this one as well. You can check the material is there. So this is 1 over 27 to the power of 7 times gamma of 7 is n minus 1 factorial, where n is 7. Okay, where n is 7. Our n is 7. So I need to substitute that. Let me just put gamma n, and where n is 7, something like that. So you have 7 minus 1 factorial, and that will be equivalent to, I don't know why my board is doing anyhow. What's going on? Times 6 factorial. So guys, what is 6 factorial divided by 2? Is 2 is power of 7 is 128. 2 is power of 7 is 128. Then 1 over 6 factorial. That's 6 times 5 times 4 times 3 times 2 times 1. So guys, I don't want to stress I don't want to waste time. I want to use my natural display calculator to do that. Okay. In fact, that's the best thing to use, because you don't need to solve it with your hand. Okay, you don't solve that with your hand. You just need to go ahead and use your calculator for it. And if you do that, you are going to have it as sorry, I'm on it. Just hold on, please. 2 is power 7. So I'll have it as 45 over 48. So guys, this is the correct answer to that question. Okay. So therefore, the integral of 0 to infinity of x raised to the power of 6 e to the power of negative 2x dx is equivalent to what? 45 over 8. That is the result for that. Okay, please take note. That's 45 over 20. So let's quickly move straight to the next one. So the next question, guys, I have to check it out. I'm coming, just hold on. For the second part, the question says integrate 0 to infinity of square root of y is power of negative y cube, then dy. So what would that give us, guys? The second question here. So remember that I said what you are interested in is this. Make sure that the coefficient of that variable is negative 1. Okay, the coefficient of the variable here is negative 1, but the problem is that it's not having cube, which is not meant to be. So I'm only expected to have e negative x. That's immediately when you have this, then that means you are free to go ahead and simplify the other one and then express it in terms of y is power of n minus 1, which you can actually do that. Okay, this one is y half, so you can transform, you can equate n minus 1 equals to half and get your n. But guys, what I'm going to do from here, so that means since I have issue with this y cube, okay, since it's not equivalent to minus y or something like that, so that means I have to use substitution method. That's the first thing that should come to your mind. What was on my board? Sorry, I have to clean this. So guys, I have to use substitution method. Now let's start. For substitution method, that means I will let u represent whatever I have here beside that comes after the negative sign, and that's y cube. So then you find du over dy. du over dy is 3y squared, and then make dy the solid of the formula, right? That means I want to transform y back to this substitution that I use, this variable that I use for the substitution. So that means if I cross multiply now, I automatically have du is equals to 3y squared dy. Make dy the solid of the formula. So I already have my dy to be equal to dy is equals to du over 3y squared. Now this is sorted out. You take note of that. Next thing is to go ahead and use, okay, this is y cube, right? I have to make y the solid of the formula as well. Okay, I have to make y the solid of the formula. Looking at this now, y cube is equals to u. Then how will you find y? How will you make y the subject? That means you just take the cube root of both sides, or multiply both sides by an index of 1 over 3. Multiply both sides by the index of this reciprocal. Okay, the reciprocal of 3 is 1 over 3. If I have 5 here, I'll use 1 over 5. If I have 2 over 5 here, I'll use 5 over 2. Just multiply both sides by an index of, when I say index, I mean power, by an index of that reciprocal that is up there. So 3 cancel 3, y is equals to u 1/3. So then I'll just take note of this. Automatically, it will not affect the range. The range will still give you the same thing also. For the range, when this range for 0 to infinity is for y, it's changing with respect to y. That is dy changing y. It changes with respect to y. So if y owns this range, that means when y is equals to 0, put 0 here, you still have u to be equals to 0. So that means for my next solution here, u still remain at 0 when y is 0. When y is infinity, put infinity here. Infinity is power of 3. That's infinity times infinity times infinity is still infinity. The u, that u is still infinity. So square root of y, that's square root of what's y? Y is equals to what? U raised to the power of 1 over 3, right? Okay, that's u raised to the power of 1 over 3. Then e raised to the power of negative y cube is what? Y cube is equals to u. We already transform this one back to u. And then dy is equivalent to what? Dy is equals to du over 3y squared. Du over 3y squared. So guys, what I need to do now here is to take this 1 over 3, the constant, outside from the integral. Then I'll go ahead and simplify this now. I have u is power of 1 over 3 and I have squared here. Anything square root, that means 1 over 3. This one is inside the full bracket. There's an invisible one here. So just take the fraction of this one and this square. Okay, that's 1 over 2. When you have square root, you take it as index of 1 over 2. So you have to solve it out one after the other in that case. So I have e is power of negative u. I have du. So I'll be left with over y squared, right? Sorry, this y squared now. I have to transform this y. What's our y? So let's do it one after the other. I only want to see just the variable I substitute. The variable substituted, that's what I want to see. I don't want to see any other letter aside from u. So this is 1 over 3 times 1 over 2. That's 1 over 6. E negative u du over this y is equivalent to u is power of 1 over 3, right? Y is u is to the power of 1 over 3. Then times, I still have the square. When you square it, so guys, looking at this, what are we going to have next? I'm going to have integral. I have 1 over 3, 0 to infinity. Then u is power of 1 over 6. Then e is power of negative u times, this is du over u is to the power of 1 over 3 all squared. That's 1 over 3 times this 2, that's 2 over 3. So you know what to do from here now. Indices. Just need to go ahead and divide. U is power 1 over 6 divided by u is, if this divide this divided by this, what will I give you? That is u is power 1 over 6 divided by u is power of 2 over 3. That's indices. That's u is power 1 over 6 minus 2 over 3. Then you find the LCM there. LCM is 6. 6 cancels 6, 1 minus 3 cancels 6, that's 2. 2 times 2, that's 4. Right? So I have it as u is to the power of negative 3 over 6. That's u raised to the power of negative 1 over 2. So if this divide this, I'll have it as u is power of negative 1 over 2 times u is power of negative u, then d. Guys, successfully I've been able to transform the expression into what? A gamma function, whereby I really have negative of the variable I have. So I'm not really interested in this one. This one is very easy for us to get. So just compare. So we need to compare it to the standard with the standard definition of gamma, which says, let me use that same variable. U is power of n minus 1, e is power of negative u, then du is always equivalent to what? Gamma n. So that means I still have 1 over 3 out there. That means I have to equate, okay, u is equals to u, correct? D is equals to du, but this n minus 1 will equivalent to what? This. So n minus 1 will be equated to negative 1 over 2, and that's negative 1 over 2 plus 1, right? Then that's n equals to 1 minus half. That's half. So my n is half. So when it comes to this place, I have it as gamma of what? My n here, this expression here is equivalent to gamma n, and n is equals to what? N is equals to half. So guys, what's gamma half? I need to explain this thing clearly now. Take note that the gamma of 1 over 2 is always equals to root pi. There's a proof for that as well. A very long proof, and we also have a shortcut for it. There's a shortcut for it. Just check it too. Okay. There's a shortcut for it. It's like just type shortcut to gamma of half. Gamma, type gamma, and then type half on YouTube. You see shortcut. Use that one. Okay. But just have this in mind always. I'm just trying to. I should have explained gamma as a topic, but let's as I'm coming across each terms, I have to explain the terms. That's why I'm trying to do that. Okay. And I don't mean I'm explaining gamma on its own. I will have explained why gamma of half is this. But we don't have time for that. We just need to go ahead and always have this in mind. Gamma half is equals to root pi. What if you now want to look for gamma of, let's say, this is 1 over 2, right? Let's say you have this 1 over 2. There are some other gamma of a fraction that you need to know. Okay. The when we get there, I'll make sure I explain. Like any gamma of something over 2. Okay. Aside if it's not even number. Now I've used 1. I've used 1. If I use 2, it becomes gamma of 1, and I can easily find that. So the next value is 3. What's gamma of 3 over 2? What would that give us? Okay. Let me clear that. What if I ask to look for gamma of 5 over 2? What would that give us, guys? Okay, if you want to look for gamma of 4 over 2, the next value after 3 is 4. Anything over 2, make sure you have it in mind. You must understand this concept that I want to explain now, because you always come across it at all time. What of 6 over 2, that becomes gamma of 3, but I can't use 6 over 2 since I already have an answer to that. So let's explain that of 7 over 2. And also, I can't use 8 over 2 because it's reduced to 4, and I can easily find that that's 3 factorial. But let's use 9 over 2 and the likes. Okay, the reason why I want to explain this one now is because there are some other questions. This is the second question now. I'm solving the second question. There are some other questions whereby after simplifying everything, you end up having, after looking for your n, you now end up having your gamma as the n. We now have it as let's say 7 over 2. And when you get to that point, are you going to leave your final answer like this? Your exam will be marked based on your final answer. If you are not correct, final answer carries the more mark. I'm very sure of that. So if you stop here and this is not equivalent to what the lecturer has, then I'm not sure that you get your full mark. So you need to understand this. Okay. So the concept is gamma of half is always equals to root pi. So when you get to this place, I'll just advise you. hmm, If you want, like saying you want to look for the gamma of 3 over 2, let's say you want to look for gamma of 5 over 2, or probably you want to look for the gamma of 7 over 2 as well. Okay. 7 over 2, and then you have 9 over 2. Sometimes you can even come across that of 11 over 2. Okay, you can come across the one of 11 over 2. So whatever you have to do here is, let me start with this 5 over 2. So the gamma of this one now, of this 5 over 2 is, you reduce this 5. Okay, what's how will I put it? List all the even number, or list all the odd numbers that this thing follows odd numbers, 3, 5, 1, 3, 5, 7, 9. Just list out all the uh, odd numbers that we have: 1, 3, 5, 7, 9, 11, and so on. So if you want to look for gamma of 5 over 2, this is why I have the 5 over 2, right? This is why I have the 5, digit 5. Okay, so you are considering just these other ones, the lesser odd numbers, the odd number that is less than 5, the odd numbers that's lesser than 5. So that means the first odd number that is less than 5 is 3. So you write 3. Okay, you have to write 3 over 2 when everything is over 2, times, what's the next odd number that is lesser than this 3? 1 over 2. Then finally multiply it by this gamma of what? By this root pi. Always multiply it by root pi. Okay, just write it as, okay, gamma of half. Everything will always end as gamma of half. That means you have to put with pi for everything. All of this one too. For 7. So this is 7. What are the odd numbers that are lesser than 7? 5 first. Right? 5 over 2. The next odd number, 3 over 2. The next odd number, 1 over 2. Then finally it's what? Gamma of half. You put with pi. Is that you write gamma of half or you write put with pi? If you want to skip your stake and put with pi. All of this one, 9 over 2. The odd number that is lesser than 9 is 7 over 2. Next, 5 over 2. Next odd number, that's 3 over 2. Next, 1 over 2. Then gamma of half. And gamma of half is with pi. So that is how it works. You can find that of 11 over 2. So 11 over 2 will be, gamma of 11 over 2 will be 9 over 2 times times 7 over 2, then like that. So do you understand? So we can easily clear this now. Please make sure you have this in mind. Okay. Now this is 1 over 3. Always have it in mind that gamma of half is with pi. That one, we don't have any issue with that. So these are final answer for the second question. So I'm very sure that by the time you solve the third question, you end up seeing something of this nature. The third one, that is if the third question is not based on. Okay, I think they said we should use gamma for all the questions. So for the gamma now, we also have another one. I gamma. Let me look for the third question. The third question says evaluate 0 to infinity of y squared e is power of negative 2y cubed then dy. So let's see how this one works as well. So looking at this, the first thing that should come to mind is to look for this, is to consider the index you have for the exponential sign that is it. So then look at it. Does it really look like negative x, negative y? So this is really disturbing. This 2y cube. You have to use substitution method for it as well. You have to use substitution method. So to use substitution method, you know what to do from there. Solution. Right now, let's look at something. That means you have to use u. Let u represent that, especially aside from that negative 2y cube. Then let's find du over dy. Du against y. Okay. Du over dy will be equals to that 6y squared. Remember that we are not evaluating implicitly. So because of that y now, you might think you are evaluating implicitly. We are not. That's 6y squared. So let's make this the y the solid of the formula and make y the solid of the formula. And then the range will not really affect. But always test for the range. Make sure you always show workings for your range. It might have that might also give you mark. So take note of that. So if I make dy the solid of the formula here, I'm very, very sure you can do that yourself. You have your dy, make dy the solid of the formula, you always have dy to be equal to du over 6y squared. Now I already have this. So do I still need to make y solid of the formula? Since I noticed that if I substitute this dy as du over 6y squared, so I don't need to make y solid of the formula because I noticed this y squared will cancel that y squared. So you don't need to go ahead and make y solid of the formula and start stressing yourself. No. Luckily for us, this y square will cancel this y square, so you don't need to do that again, or else it will take your time. So I'll have 0 to infinity. Y square, you leave it as y square. This is e, negative. This one has already turned to u. We already substituted y cubed to be u. And then dy is equivalent to what? Du over 6y squared. So can you see what I'm saying? Had it been I've transformed this y now, this one will change. But automatically this will cancel this. So always check before you go ahead and make y. Always check whether this down part can cancel whatever you have up there. If yes, then you can go ahead and simplify. So I have 1 over 6. 1 over 6 will come out as a constant. 1 over 6 will come outside. So I'm left with 0 to infinity of e raised to the power of negative u. Please, y square cancel y square, there's an invisible one. So I can actually remember that I have something at the back. Okay? Y square here 1, y square here 1. 1 divided by 1 is 1. So 1 is still there, and I have du. So how can you relate this with how can you compare this with the standard gamma function? 1 over 6. Okay, the standard gamma function, the definition for gamma function is x is to the power of n minus 1. So I think I'm dealing with u now. So I do not get confused. Let me use u is power of n minus 1, e is power of negative u, then d. That means I don't have any issue with e is power of negative u. This is correct. But I have issue with this one. I have 1, right? So that means whatever I'll just have to do is to go ahead and transform this one to something like u is to the power of 0. So that u is power of 0, this one here is equivalent to what I have here. Take note. 1 is u is power of 0, which is still 1, negative u. So I can easily compare now. That is u is u, e is e, negative u is negative u. So I'm only left with this to just find n. That means n minus 1 is equivalent to 0. And that's n is equals to what? 1. So that means whatever I will just have to do here is to write 1 over 6. And then this one is equivalent to gamma of what? Gamma of n. All this one is gamma of n, and n is 1. So guys, what's gamma of 1? Gamma of 1 is equivalent to n minus 1 factorial So that is where n is equals to what? This n, right? Gamma of n. Where n is 1, that's 1 minus 1. What's 1 minus 1 factorial? That's 0 factorial. And right one, mathematics is 2. 0 factorial is always equals to 1. Take note. So there is no problem about that. So this is equivalent to 1 over 6 times 1. And the answer is what? 1 over 6. So I think that is clear now. So let's quickly move straight to the next one, which is the fourth question, number 4. It says find the gamma function of this x squared e negative x dx. So this one too is simple. This one we don't have any issue with this one. Looking at this now, I already have negative x, so we don't need to use substitution method. Can you see that? Thank God it's just of this form. We don't have any issue with the index for the exponential. So that's just what you need to consider at all times. So this is the standard definition for gamma. So that means x is x, e is e, and negative x is negative x. So I just need to compare this a minus 1 and these two together. So that means n minus 1 is equals to 2. So for n, that means n is 3. So that means final answer is just gamma n. And what's my n? That's gamma of 3. And what's gamma of 3? N minus 1 factorial. Okay, that's 3 minus 1 factorial. Just take this 3 and then put minus 1. And that's 3 minus 1 factorial, that's 2 factorial. And what's 2 factorial? That's 2 times 1 times 0 factorial. And that is what? 2. So the answer to this question is 2. So I think I'm almost done with the gamma question for this question 7a in your Math 242 practice question. So I have question number 5 as this. So looking at this one too now, I also have one here. Indicate the one so that you know that I can see it, but that is not really necessary. But I'm only considering the index on this exponential sign. So I noticed that there's an issue. I really need to have x, not x squared. So that means I'll use substitution method. Use substitution method, listen. So now let's use substitution method. That is, let's u represent x squared. Now du now will be equals to 2x du over dx, right? So if you make this dx is to the formula, automatically you should have it as du over 2x, right? In fact, that x will come out at the end of the day. So I can go ahead and substitute. It does not really affect the limit. If you set it for the limit, it still give you 0 to infinity. So you can go ahead and substitute. This is e raised to the power of negative x squared is equivalent to u, and then dx is equivalent to du over 2x. So you know what to do from here. The constant goes outside from the bracket. 1 over 2 will go outside from the integral rather. So I'll be left with just 1 over x. And this 1 over x is equivalent to x raised to the power of negative 1, right? Then I have e raised to the power of negative u, then du. Now we have a problem. That means this x, I have to find x here. Okay? Since x, I can't have u and x. I'm integrating with respect to du, so everything should be in x. The variable should be in x. That means I'll make x equal to the formula here. So if x squared is equals to u, so you take the square root of both sides. Square cancel square root. So x is equals to u raised to the power of half, if I'm not mistaken, right? That's u raised to the power of half. So that means I'll just come here and then substitute what x is. What's my x? X is u raised to the power of half. Remember that I still have a negative sign up there, right? So finally, we have it as 1 over 2 integral of 0 to infinity of u raised to the power of half times minus 1, that's minus half, e negative u du. So we don't have any issue with this power on the exponential. It's now standby now. Okay? So that means I can compare. Compare now to that of 0 to infinity of u raised to the power of n minus 1, e negative u du. So if I compare, that means e is e, negative u is negative u, du is u, u is u. So the only difference is this power. So you can easily equate the power to get the value for n. N minus 1 is equals to negative half. So take this one to negative 1 to the other side. I have negative half plus 1. And what's 1 minus half? That's half. So that means I'll just bring this 1 over 2 down. And I'll have this expression here as gamma of n. And my n is half. Right? So since my n is half, what's gamma of half? Gamma of half is pi. That's pi 1 over 2 pi. So this is final answer 1 over 2 pi. Guys, I think that's all for question number 7 for gamma function. Please take note of this my explanation for gamma function. Aside from the proof, we have some other proof as well. You ask to prove. That one is certain, but at least make sure you just understand the basics. These are the basics. So I'm done with gamma. So aside from the proof, like I said. So the next thing for us to do is to answer question 8 in the tutorial question, which is for they say we should use beta. Use beta function. Okay, to evaluate the following. So that's what I want to do. We have up to 10 questions in that one for better function. So I'll do that in the next video. So let me just go ahead and save this and then upload it to my YouTube channel. So I think that's all for now. So thanks for watching.